In this part of the video, we are discussing about how to refer the life table in exam and answer a question using the life table. So up to now, we have discussed how to calculate these annuities and present values of benefits in different ways using summation and integration. But in here, if you are asked to use the standard ultimate life table, so then you don't need to worry about these integrations and the other calculations. We have all these for the interest rate of 5% in a tabular form. So what we have to do is just refer this table and get the corresponding value. For an example, if your age referring to is X and it is given in the first column, and suppose it is 25, so then we have the number of survivors at the 25, the death probability from 25 to 26, and the whole life annuity starting from 75. It is a discrete and annuity due, and the present value of the whole life insurance of $1, and the variance. To get the variance, you can use this second movement, and this is the first movement. You can calculate the variance using these two, and the annuity due of a 10-year annuity, and this is the present value of an insurance, which is, now you can see it is not a term life, it's an endowment insurance, and this is for 20 years for both cases, and this is the PO endowment present value for 5 years, 10 years, and 20 years. Likewise, we have most of this information in here. What we have to do is just refer the corresponding age and then refer the corresponding value you can do. So we know that if we have this whole life and the term life, then eventually we can have the deferred whole life. And if we have the pure endowment present value, then we can find the present value of the term life using the endowment present value. And also in the next chapter, we will use both of annuities and the present value of the benefit to calculate the premium. So before going to the premium calculation, finally, we will discuss about this example where we are asked to refer the standard life table with the 5% interest rate and the present value random variable for a 5-year fully discrete life annuity due at 65 years of age uh, should be taken into the consideration to calculate the variance of that present value y. How to begin with this one? So we need to find the variance of y and we know that to be specifically, we need for term life and the whole life, we can have the corresponding whole life annuity and the discrete life annuity due for a limited term using that YZ relation. So if we could find the present value of a term life benefit at 65 years of age, and the term goes for 5 years, so then we can divide it by the d square. So that means we have the second movement, and then we need to find the first movement. For 5 years and divide it by the d square. Now to find these two, let's go to the table. And yeah, in here we can find the whole life first movement and the whole life second movement. So what we need to do is, first we need to calculate, since we need to find this endowment second movement. So the endowment second movement is not given, but we can derive it. We know that we have to replace delta by 2 delta, and then we can get the corresponding second movement. So to do so, since we have an equation to calculate the term life using the given information, first we need to find the first movement of a term life starting from 65 for 5 years. So it is whole life 65 subtracted from the present value of a deferred whole life, which is at 70. So to go to the 70 from 65, we need 5 more years. So the present value of the PO endowment of that case is 5. And you can find these three quantities in the table. If we go to the 65th here, so we have the whole life 65 here and the PO endowment part in here and the whole life 70 in here. So extract those three numbers and we get 0.35477 subtracted from 0.75 and 455 times 0.42818. So the resultant value is 0.031,687. Then we can calculate the first movement of this endowment for 5 years. So in here, the endowment is given for 10 years and 20 years. So that's why we use this approach to calculate the endowment for 5 years. So this is given by the summation of term life plus so this is given in the table and this is what we found, and the resultant value is 0.78 624. Then to get the second movement, we need this, which is given from the same equation. Now, instead of the first movement, we will have the second movement of the corresponding equation in here. So we get this. In here we have the whole life second movement. So we can take it directly from there. For this one, we know from that expression. So this is the discounted value or the discounted factor times the first movement. So that is because if we make it 2 delta, so we can take 1 v to the power delta out of that. So that means for this one, if you rearrange this, so this will be V5 times E65 5. So all these are given in the table. You can find the final value directly by substituting these two from the table, and the final value should be 0.02725. So in the similar way, since we have the second movement for the term life, we can find the second movement for the endowment. Using this equation. And we know how to calculate this one, and we have already calculated this one. So value is 0.61809. So once you have this, you can get the variance of y Now the equation should be like this. So that means 78624 to the power 2 divided by the d square means I divided by 1 plus I to the square. You will get the final answer from here. So that's a demonstration of how to use the table and extract the numbers to do the calculation. Now you can see the only thing you need to know is how to manage and derive these new equations. Once you figure out the equation and the expression, you just need to substitute the values and get the final answer by going through the simplifications and calculations. So that's how we can use the table to find the present value of an annuity and also the benefit payments in future. So in the next chapter, we will use these kind of things and calculate the premiums for different kind of policies. And that will be the last chapter of the lecture series.